So, with the backdrop of the volunteer fire department sirens, we'll talk some organic chemistry, but don't worry, it won't be that alarming. It'll be fine. So, we're going to pick up on page 11. We may not have finished all the way through page 10, but you've learned enough now between alkanes, alkenes, and alkynes, and naming in general that you're going to be able to pick this up. And if we have to pick up the pieces with page 10, that's not a big deal. Page 11 begins the next chapter, the second chapter in the organic unit, chapter 26, and it has to do with functional groups and organic reactions, although to call it that's a little bit unfair because really it's mostly about functional groups. And we'll have organic reactions at the very end, and we'll do a little bit of group activity with it, and that'll be fine, but most of this continues to be a naming exercise where you're learning all different kinds of compounds now and how to name them. But the good news is that the rules remain the same. You're always going to minimize the numbers. You're going to be looking at all of these same things that you were looking at with alkanes and branches. So let's define what a functional group is. And we can't say circular definitions. That would be a group that has a function, but it's true. It's an atom or group of atoms which has a certain reactivity. Every functional group we're going to learn about has its own set of reactions. Now, I've talked about this before. I'll say it again. Organic chemists do not sit at a table all day naming compounds and writing new ones and passing them across the table and trying to stump their friends. They actually are concerned with making things. But before you can talk about reactions that you can do, you need to be able to talk the talk before you can walk the walk, and that's exactly what we're doing here. We're going to continue to learn how to name things, and we're going to name molecules that have functional groups, but we aren't going to talk too much about their function until the very end of the unit, and that's about how far as this first exposure to organic chemistry goes. There are lots of types of molecules which possess functional groups, and if you look at table R, which is, well, you should look at table R, but it's also page 12 of your notes, you will see that there are many different kinds of functional groups, different kinds of classes of compounds that have functional groups. So what I'd like you to do is I'd like you to write down all of these as a list on page 11. You're going to write down halocarbons. You can write halides, but I actually prefer halocarbons because halides refers to just anything in group 17. Halocarbons implies that it's a group 17 containing organic molecule: alcohol, ether, aldehyde, ketone, organic acid, ester, amines, and amides. And this is the list of molecules that we're going to learn how to name. So you can press pause now and write all that list in there, but that's what belongs here, where it asks for types of molecules which possess functional groups. Now, the good news is, now I imagine you've paused and written it down, and that is one thing you're going to have to show me tomorrow. The good news is that you have reference table R for anything you might need. And we're going to be marching our way through these different kinds of compounds over the next couple of days. And the good news is that you're going to have a model for how to name any one of these kinds of compounds. And you see some of them have numbers and some of them don't. Good news, and you can write this down as a note to yourself on page 12, because there's nothing that you really need to write on page 12, but you can write this down. Anything here that has a number has the potential of needing numbers, just like not all alkanes needed numbers, but some do. Any of these compounds that are listed with an example that has a number may need a number. Anything here, though, that doesn't have a number will never need a number. So no organic acid will ever need a number. No ester will ever need a number. However, it will be possible for an amine to have a number. So anyway, we're going to march through, not pretty much in order, actually, almost in order. And the first couple that we're going to do are indeed the first two. They're halocarbons and then alcohols. So what does it say here on the top of 13? It says just about everything you will need can be found on this table. The rules for naming haven't changed. Minimize your numbers, and a few of these don't even need numbers. Now, one thing you may notice on table R is a bunch of R's all over the table, and what could they possibly mean? They represent side chains. They represent organic groups, not like, just an oxygen or just a chlorine or whatever, but a whole hydrocarbon chain usually. And actually, that's what it says here. It represents a bonded atom or group of atoms. Typically speaking, for this table, because we're in organic chemistry, it's going to be a carbon-based side chain. So we write that down. R is a side chain, often a hydrocarbon side chain. Now let's talk about halocarbons. What are the halogens? You should be able to write down the halogens, and if you don't remember, go back into your periodic table notes and write down the 4 main halogens. That's what I need you to do. Now it turns out that they can take the place of a hydrogen or an H in a hydrocarbon. Is the molecule at that point still a hydrocarbon when a halogen has taken place of one of the hydrogens? You got to say yes or no, and that's part of your homework, so write that in. The naming is as usual. So if you were asked to draw 2-chlorobutane, again, this might be as we've talked about in class, this is the easier direction, right? I give you the name, you draw the molecule, you draw a butane, and then at the 2 position, you put a chlorine. And what does that look like? Oh, I had it. I thought I had it already set up to paste. Well, there it is. I'm going to copy and paste it in. This is 2-chlorobutane. No, it's not letting me paste for some reason. All right, well, I'll put it up here anyway. There we go. 2-chlorobutane. Check it out. You have the 4 carbons in a row right here. And then at the 2 position, 1, 2, here's a chlorine. 2-chlorobutane. It's almost the same as we were doing with alkanes, whereas like 2-methylbutane. Well, now instead of a methyl, a CH3 group, it's a chlorine, so a Cl group, and so we say chloro. And if we look back at our notes, and we look at table R, we will see that indeed the rules for any halocarbon is you write fluoro, chloro, bromo, iodo, depending on what the halogen is, and you write that one in with an O on the end. So 2-chloro, in our case, it was butane. In the example here, it's propane. So 2-chlorobutane is this molecule right here. And what I want you to do, and this is part of your homework, is I need you to do these 3 other molecules. 2,5-dichlorononane, 3-chloro-2-fluorohexane, and 1,4-dibromobenzene. Now, if we haven't done page 10 yet, and of course I'm making this Sunday night, so I don't know, but if we don't make it to talking about benzene, you can skip this one. But if we've talked about benzene, you need to do it. But these are the 3 that I'd like you to do right now. And we'll talk about the use of halocarbons in class on Wednesday. I'd like to skip right ahead to top of page 14, or just a little bit down from the top of page 14, talk about alcohols. What do we use every day that has an alcohol in it? Alcohols are in things like Purell, other hand sanitizers, of course, rubbing alcohol, that's used commonly for disinfecting. All of these have different kinds of alcohol groups. Now, what is the functional group that makes something an alcohol? Something in alcohol? That should be an A. Sorry about that grammar there. Functional group that makes something an alcohol is, and you need to look at table R and fill in that blank. And we'll continue. However, unlike other functional groups, this is a suffix. Whereas before we were saying chlorobutane, bromopentane, now we have a suffix, and at the end of every alcohol, we end with OL, all. For instance, CH3OH has 1 carbon, and so we call it methanol. Methanol. And if you remember back from the acids and bases unit, I told you this was one of those odd ones that's not an Arrhenius base. Well, here it is, methyl alcohol, methanol, an alcohol with 1 carbon. And then I want you to write down what you think this next one would be, which is an alcohol with 2 carbons. Not rocket science, but I want you to fill it in. Now, when we get past, another spelling mistake, when we get past those 2, we need to specify where the OH group is. So in your notes, you see 1-propanol listed there, and I want you to circle the first carbon that bears the OH. And then I want you to draw 2-propanol, and that's the end of this video for you. So that's the end, bottom of page 14. Make sure you have 2-propanol written in your notes, and we'll check on it tomorrow. Great.